Alright, you guys, so here we are with another lesson. This is going to be for slant asymptotes, otherwise known as oblique asymptotes. And this is when we're going to be talking about rational functions. So we have the definition here. So a slant or an oblique asymptote occurs when the polynomial in the numerator is exactly 1 degree higher than the polynomial in the denominator. Remember that the word degree here means the exponent. So when the exponent is one number higher in the numerator, then that's when you're going to have a slant asymptote. Okay, to find the slant asymptote, you're going to divide the numerator by the denominator using long division, and the equation creates a line. So I wrote down the steps for you. They're kind of wordy, but I wanted to make it as clear as possible so that when I'm not with you, you're able to solve these and follow it on your own. So step 1 is to divide the term with the highest degree from inside the long division symbol by the term with the highest degree from outside the long division symbol. The second step is to put the quotient on top of the long division symbol and then multiply every term from outside the long division symbol by this quotient. If the product is positive, you won't be putting a plus sign because the next step is to change all the signs. So if it was supposed to be positive, you'll make it negative. If it was negative, you'll make it positive. And then you're going to combine like terms. And you're going to keep repeating steps 1 through 2 and 3 until the degree inside is lower than the degree outside the long division symbol. Your final answer will be y equals and then whatever the quotient was on top. And then to check, you can graph the original function and your slant asymptote with the remainder. So sometimes you'll have a remainder, just like you would if you were dividing regular numbers. So you'll put the slant asymptote and then you'll do plus the remainder on top and the original denominator in the bottom. And they should be the same graph. So if they're not the same graph, then you probably did something wrong, and that's a good indicator to go back and double check your work. So I know this seems like a lot and it's overwhelming, and it probably does not make any sense. But we'll do some examples, and then hopefully it kind of starts to make more sense in your head. So I'm going to start with just some really easy examples, probably from like elementary or middle school. I have no idea when you learned how to do long division. But example 1 will do 252 divided by 2. Okay, so remember the denominator goes outside of the long division symbol, and then the division symbol looks kind of like this. And then you'll put the numerator inside. And so essentially you start at the most left side, so it would be this number, and you'll try to figure out what number times this number will give you a 2, right? So we know the highest number there would be 1, so we know that 1 times 2 will give you 2, so you'll put a 2. But then after you put the 2, so it's a positive 2, but we're going to change the sign to a negative because we're going to want to subtract, right? So 2 minus 2 cancel out, and we carry down the 5. And now we repeat this process. So how many times does 2 go into 5? So you're essentially dividing 5 divided by 2, okay? It's only 2 times that can go in there, so we're going to put a 2, and then you multiply that number by the number outside, so that's 2 times 2, which is 4. Again, it was a positive 4, but I didn't put a plus sign because the next step is to change the sign. So you get 5 minus 4, which is 1. So now the next step will be to carry down that 2 from the top and then figure out how many times does 2 go into 12. And you can do that by dividing the inside number by the outside number. So 12 divided by 2, we know that is 6. So I'll put a 6 up here, and then you'll multiply 6 times 2, which is 12, and you put that number here. Again, if it's positive, don't put the plus because the next step is to change the sign and then combine like terms. So 12 minus 12 is 0. So here the final answer was 126 with a remainder of 0. Okay. So that's the first little review. Let's do another one. Example 2 is 452 divided by 7. So again, put the denominator outside, put your long division symbol, and the numerator goes inside. So you start, how many times does 7 go into 4? So you would do 4 divided by 7, but that is not possible. So we're gonna have to think bigger. So we'll do 45 divided by 7. And so the highest number that can go in there is 6. So we'll do 6, and then 6 times 7 is 42. So we'll put a 42 right below that. Again, we're going to change the sign from positive to negative, and we're going to subtract. So 45 minus 42 is 3, and then you bring down the 2. So now you're going to do the same thing again. How many times does 7 go into 32? On the side, you can essentially just think about it as, dividing by 7. And then the highest number that would go is 4. Okay, and then you would do 4 times 7, which is 28. And you would put that there, change the plus to a minus. And then 32 minus 28 is 4. Okay. And so now you would keep going. So you would figure out how many times does 7 go into 4. But this is the same problem we ran into earlier. So basically, when the number on top is smaller and the number on bottom is bigger, then you stop here. So essentially, this number becomes your remainder. So our final answer here will be 64 with a remainder of 4. Okay, so that's our little review of long division. So this is basically what we're going to be doing to find the slant asymptote, except we're going to be adding variables. So it's not just going to be numbers. So here's our first example. So we have f of x equals x squared minus 6x plus 7 divided by x plus 5. So basically we're dividing polynomials using long division. It's all it is. So we're going to start by putting the denominator outside of the long division symbol, just like we had done in the previous problems. Put your long division symbol and then put your numerator inside. Okay, so before we started on the term closest to the edge, and that's going to be the same here. And then you're going to start with basically the highest degree on both sides. So the highest degree here is 2, and then the highest degree here would be 1, because remember this one is 0. Okay, so you're basically going to, and on the side I recommend you do this, you're going to divide x squared divided by x. Okay, we can rewrite this as x times x over x. So one of these x's cancel that one from the bottom, and you're just left with 1x. Now, whatever you get here, you're going to put up here at the top. So now at the top, I have 1x. And so what you do is start multiplying the top by everything on the outside. And I'm going to do one term at a time. So first, I'm going to start with x times x plus 5, which gives me 5x. And I'm going to strategically place that underneath my other term that only has 1x, because that'll make my next step combining like terms easier when they're below each other. So I'm going to do 5x. Now, notice that even though it was a positive 5x, I did not include the plus symbol because remember the next step is to change sign. So I'm going to just leave it like that for now. Now, I'm going to multiply x times the other x, and that'll give me a positive x squared, again leaving out the positive sign. Now, the next step is to change the sign. So this was a positive, I'm going to change to a negative. The 5x with a positive, I'll also change that to a negative. And then I'll combine like terms. So x squared minus x squared cancels out. Negative 6x plus negative 5x is negative 11x. And then you're going to bring down the plus 7. And you basically start all over again. So you're going to divide. the highest degree. So remember, this has a degree of 1 and this one has a degree of 0. So this one is higher, and then this one is higher on the outside. So you're going to do negative 11x. So I'm going to do this one divided by this one. Negative 11x divided by x. So the x's cancel. This x cancels out that x. So all you're left with is negative 11. That you're going to put up at the top. So we got minus 11, and then you multiply. So you got negative 11 times positive 5, which is negative 55. And then negative 11 times x, which is negative 11x. Now, if your numbers are negative like mine, do put the negative, because the next step will be to change it to a positive, okay? So again, the negatives become positive on both terms, and then we'll combine like terms. So negative 11x plus 11x cancel out to 0, and then 55 plus 7 gives you 62. Now, your next step would be to try to divide again. So it would be 62 divided by x. But now notice that that's not possible, okay? So on this one, there was a degree of 2 and 1 at the bottom, so this one was higher. These two, it was the same. So that's okay as well. So it could be higher or the same, but this one, it's higher at the bottom because it's 0 at the top and 1 at the bottom. So this is when you stop. So that means that the number 62 is going to be your remainder. Now your slant asymptote is only what's up at the top, basically your quotient, okay? So I'm going to write the slant asymptote is equal to y equals x minus 11. Now you don't include the remainder in the slant asymptote. The slant asymptote is only what's on top. Now if you want to check, you're going to graph this. Let me see. To check, graph y equals x minus 11, and you're going to do plus the remainder, which was 62, over the original denominator, which was x plus 5. Okay, so let's go ahead and put this in Desmos so you can see if we did it right. Okay, so I have already pre-graphed the original, which is x squared minus 6x plus 7 over x plus 5. When you do it on your own, you might get something that looks like this, but these are rational functions, so you should have two sides at least. So make sure you're zooming out until you see the full picture. Okay, so now that I see both sides, I'm going to put my slant asymptote, which was x minus 11. So notice that that blue line goes right in between the two sections of the rational graph. Now, if I want to see if my slant asymptote is correct, I'll do the slant asymptote, but then at the end, I'll do plus the remainder of 62 over the original denominator, which was x plus 5. And so notice that the red and the green graph overlap each other because they're the exact same. And so that's how you know that you did it right with the correct remainder and everything. Okay, so that is correct. So I'm just gonna box that in. And let's go on to the next example. So f of x equals 3x squared plus x minus 2 all over 2x plus 6. So again, we'll start by putting the denominator outside, do your long division symbol, and then put the numerator inside. Okay, so you'll start with the highest degree, which is the 2, okay, because this is 1 and this one is 0. And then the highest degree on the outside, this one is 1, this one is 0. So you're basically going to be dividing 3x squared divided by 2x. As you get better at this, you may not need to do this division on the side. You could probably do it in your head. But for right now, I'm just showing it so you know where everything is coming from. Okay, So again, you can rewrite 3x squared as 3x times x. So that makes it very easy to see that one of the x's cancels one x from the bottom. And so we're just left with 3x over 2. So that's what's going to be going up on the top. So we got 3 over 2 times x. So now you're going to multiply this by every term here starting from the right. So 3 over 2 times 6. So 6 times 3 is 18. 18 divided by 2 is equal to 9. So I will put a 9x down here. Again, don't put the plus sign. Now moving on to the next term, 3 over 2 times 2x. So the 2 times 3 is 6. 6 divided by 2 is 3. And then x times x is x squared. So that ends up with 3x squared. So I know some of you guys struggle with fractions. So as you're doing this by yourself and you want to use the calculator for the fractions, that's okay. All right, next step is to change the sign. So if it's originally a positive, we'll make it a negative, which they were both originally positive. So I'll change both of them to negative. And then I'll combine like terms. So the 3x squared minus 3x squared cancel. X minus 9x becomes negative 8x. And then you bring down whatever is left over. Okay, and then you basically repeat the process. So we're going to do the highest term from the inside divided by the highest term from the outside. So that becomes, we're going to do these two. So that's negative 8x divided by 2x. So this x cancels that x, and then you just end up with negative 4, which is going to be up here. So we'll do negative 4 times 6, which is negative 24. And then negative 4 times 2x, which is negative 8x. Okay, the next step is to change the signs. If it's negative, make it positive. So I'm going to change both of them to positive, and then combine like terms. So the 8x and negative 8x cancel out, and then 24 minus 2 is 22. Okay, now if you were going to try to do this one more time, you would do 22 divided by 2x. If you try to do that though, notice that now that the degree is higher on the bottom. So this one was higher on the top, right? The 2 is bigger than the 1. Here they were the same, they were both 1 and 1. On this one though, it's 0, and this one is 1. So when it's bigger on the bottom, that is when you stop. So here you cannot divide anymore. So that's going to be our remainder. So I'm going to write our slant asymptote is that y equals 3 over 2x minus 4. And then to check graph, you're going to graph the slant asymptote, which is what we just wrote up at the top. And then you're going to add the remainder, which was 22, over the original denominator, which was 2x plus 6. Okay, so let's go double check our work to make sure we did it right. So I did already graph it. So again, it might be too zoomed in when you first graph it, so just zoom out so you can see everything. So I'm going to graph our slant asymptote, which was 3 over 2x minus 4. So notice it goes right in between. And now if I want to check if it was correct, we will regraph the slant asymptote. But at the end, we're going to do plus, and then a fraction with the numerator being the remainder, and the denominator being the original denominator from the question. So notice that the red is the original, the green is the slant asymptote with the remainder, and notice that they overlap. They are the same exact graph, meaning that we have solved the slant asymptote correctly. So I'm going to go in and box in my final answer. Okay, let's do one more. So we have f of x equals 5x cubed minus 8 all over x squared plus 3x minus 1. So again, you'll start by putting your denominator outside. And your numerator inside of the long division symbol. And you're going to divide the highest degree term, here it's x cubed, by the highest degree outside, which is x squared. So we're going to divide 5x cubed by x squared. So we got 5x cubed and x squared. So we could rewrite this, as 5x times x squared all over x squared. So notice that the x squared and the x squared cancel, leaving only 5x. Okay, so we got a positive 5x at the top. And then you multiply this by every term here, starting from the right-hand side. So we got 5x times negative 1, which gives me negative 5x. Now notice that there is no like terms. So before I was aligning the like terms above each other and below each other, but there's no other, just x. So we have an x cubed and a constant. So I'm just gonna make sure to put this like somewhere over here because there are no like terms on that one. So I'll do negative 5x. And then I have 5x times 3x, which is 15x squared. Now, I know that these are not like terms either, but I have nowhere else to put it, so that's okay. I just wanted to create space because we will have the one last term over here. Okay, 5x times x squared is 5x cubed. Okay, the next step is to change all the signs. So if it was positive, this one was positive, so I'm going to change it to negative. This one also was positive, I'll change it to negative. This one was negative, so I'll change it to positive. Okay. Now moving on to the next step, which is combining like terms. So the 5x cubed minus 5x cubed cancel out. And now none of these terms that are left over are like terms, so I'm just going to write all of them in increasing order by the degree. So the x squared first, then the x, then the constant number. Okay. And so we're going to just repeat the same steps. I keep switching colors. I don't even think I have a method anymore, so I'm sorry. We're going to divide the highest term from inside with the highest term from the outside. That's negative 15x squared divided by x squared. Okay, and you'll notice that the x squared cancels with the x squared, leaving just a minus 15. Which will be placed up at the top. Okay, and then we'll multiply everything again, starting with the negative 1. So negative 15 times negative 1 is positive 15. And I'm going to put that with the other constant number, which is right here. Again, don't put the plus sign, just put the 15 if it's positive. Then negative 15 times 3x. Which is negative 45x. And then we have negative 15 times x squared, which is negative 15x squared. Okay, now we'll switch all the signs. So negatives, these two negatives become positives, and the positive becomes negative, and we will combine like terms. So the 15x squared cancel out the 15x squared. The 45 plus 5x becomes 50x, and negative 8 plus negative 15 is negative 23. Okay, so let's say you would keep going, so dividing the highest term from the inside with the highest term from the outside. So that's 50x divided by x squared. Okay. And that's not possible again. So notice that the 3 is bigger than the 2 and the 2 are the same, but here it's bigger on the bottom than the top, because don't forget that there's an exponent of 1 when a variable doesn't have 1. So again, when it's bigger on the bottom, that is when you stop. And yes, your remainder can be at this long. It can have variables in it. It doesn't just have to be a number. So it just depends on the type of equation that you are given. So here we'll say that the slant asymptote is y equals 5x minus 15. And then to check, you're going to graph the same slant asymptote, and you're going to add, so you're going to do plus, and the numerator will be the remainder of 50x minus 23, and the original denominator, which is x squared plus 3x minus 1. And so let's go over to Desmos to make sure that that is true. Okay, so here I have it graphed, 5x cubed minus 8, blah, blah, blah. And this is what it looks like. So zoom out so you can see the full thing. This one you gotta zoom out quite a bit, but it looks kind of weird, but that's what the graph looks like. Okay, so we said our slant asymptote was 5x minus 15. Okay, so you can see that it kind of goes through the little loops. So with the slant asymptote, you can cross the graph, and there's an example here that it did cross right in the middle. So it's kind of similar to the horizontal asymptote. So the horizontal and the slant asymptote, you can cross them. So this is just an example of when it does. Okay, now to check if we did it right, we'll regraph the slant asymptote of 5x minus 15. But we're going to add a fraction where the numerator is the denominator, which was 50x minus 23, and the denominator is the original denominator that we started with. Okay, and notice that the red and the green line overlap because they are the exact same graph. So when that happens, that's how you know that you did it correctly. So we can go back and be confident that our slant asymptote is correct at 5x minus 15. Okay, so those are a few examples on slant asymptotes. So hopefully these steps make more sense to you now. I know at first glance it was probably very overwhelming. So I hope it makes sense. And as always, we will keep practicing when we are in the classroom. All right, see you guys next time. Bye.